Today's video we're going to learn about gas stoichiometry, which is just like other stoichiometry except involving gases. And really what changes is just the way we figure out how many moles of gas we have. When we're talking about solids or pure liquids, we could measure them in grams. Gases, you can't quite do that the same way, so we have to use other factors to determine it. So there's one really easy way. If you're at standard temperature and pressure, it becomes super easy. All you have to actually do is use the mole ratio. And the reason for that is because 1 mole of any gas takes up the same volume at the same conditions. So if I asked you how many liters of carbon dioxide could be produced from 50 liters of oxygen with excess methane, all you'd have to do is look at this chemical equation and look at the relationship between the two things we're asking about. So I'm giving you oxygen and I'm asking how much CO2 can be produced. So I did it out where I went from liters of oxygen to moles of oxygen, and then from moles of oxygen to moles of carbon dioxide, and then from moles of carbon dioxide to liters, and I showed that work. But realistically, if you're dividing by 22.4 and you're multiplying by 22.4, you don't even have to do that step. So you can just get rid of it. And all you have to do is look at the ratio from the balanced equation. So if you have 50 liters of oxygen, and you have 1 mole of carbon dioxide for every 2 moles of oxygen, you'll get 25 liters of carbon dioxide. Now, if you're not at standard conditions, or you're not at the same conditions, it doesn't have to be STP, but as long as the conditions don't change, you can use that. If the conditions are changing, you would have to use the ideal gas law to calculate the number of moles of the gas you have. So if I ask you how many grams of water can be produced from 50 liters of methane at a pressure of 2 atmospheres and a temperature of 300 Kelvin, what we would first do is use the ideal gas law, rearrange to solve for moles, and figure out how many moles of methane we have. And then from that, we'd use the stoichiometric ratio of water to methane that we have, 2 to 1, to figure out the moles of water. And then lastly, since I asked for grams, you would multiply by the 18 grams of water per mole that you would have to find the final answer of 146 grams.